Alright, so let's consider this following problem. Suppose the amplitude of EM wave is 1 volt per meter. What is the average intensity and radiation pressure? Okay, so let's recall basically what this looks like. So you have a EM wave like that, right? And this is the amplitude right here. This is E0, okay? So basically the EM wave has electric field E0 cosine omega t, right? Whatever that is going to be. All right, and it has a B field, right? Which is B0 cosine omega t. Okay. All right, so let's go ahead and figure out what this needs to look like. So let's recall that the energy density is 1/2 epsilon 0 E0 E squared actually. Okay. So the average energy density, right, is the average of everything, 1/2 epsilon 0, the average E squared, okay? All right, so now this thing is just 1/2 epsilon 0, the average of E0 squared cosine squared omega t, okay? Now, this thing is a constant. Averaging this over a period will just give me a 1/2, right? So in fact, this is 1/2 times 1/2 is 1/4 epsilon 0 E0 squared, right? Now that's U of E. Now, the other critical piece is that basically U, that's the average UE, okay? The average energy is just average UE plus average UB. There's a magnetic field part as well. This also gives me a 1/2 as well. So the result is basically is 1/2 plus 1/2, 1/4 plus 1/4 is going to be 1/2 epsilon 0 E0 squared. Okay. Now this E0, as we've given basically above, is 1 volt per meter. So it's basically 1 volt per meter. Okay. And what I want to do is I want to basically convert this thing into something that I can basically state as intensity, right? So in order to do that, what we're going to do is the following, okay? So the intensity I, right, is equal to, let me just get this right. Now this intensity I is equal to basically is the average energy density times C, which is speed of light, okay? So let's just plug all that in together. So it's 1/2 epsilon 0 E0 squared times C, all right? So that's basically 1/2 epsilon 0 C times E0 squared, all right? And then for the rest of it, you can just plug everything in that needs to be plugged in, all right? Now, so that's the intensity. So now suppose we want to figure out what the radiation pressure is going to be. Well, the radiation pressure is something pretty simple, okay? Turns out that that is just simply going to be, let's get this right. Yes, this is simply going to be, for part B, the radiation pressure, P rad, is just going to be basically the flux over C, right? This is flux is usually integrated over angle for I, right? So you could think of this as basically I over C, right? And so that's just simply 1/2 epsilon 0 E0 squared. Okay, so hopefully that was helpful.